impromptu video on the LPO program. We're conveniently located at the main entrance, A1. Look immediately to your left. You can see to the left, you'll see the entrance to the laser lab. That's usually doors closed. But this is an optimal position looking back here. When the high school students, they get dropped off door-to-door treatment here. Come into the main foyer. And we actually have an LPO, an old LPO advertising poster up. And if you look down the hallway here, you've got the mechatronics program, which we're kind of joined really at the hip with here, but you got nice windows to look in and see what's all going on inside there with the trainers. Just hide the look in here. And come down this way here to the hallway, and there's nothing here that says anything about lasers. It's kind of a hidden treasure. My mind. But to come to the doors, we've got a central area we call mission control in here. And we do most of our briefings. We have outreach events and things. And from in here, we've got a desktop unit that can be broadcast on all the cameras throughout. Lose the masks, I'm in here by myself right now, but we have all kinds of equipment in here. It's like a giant fabrication laboratory. We've got a UV laser and a station that's all been built by students and modified over time in the connectivism rationale. And we've got a fiber laser that's yet to be commissioned. We'll take a tour through Lab A. This is more of our intro program set up in here, where each one of these desks is outfitted with a bunch of equipment to run the first semester course. There's actually a second semester course that's in progress right now, and the desk in the middle. My college students are on a kind of a hybrid program where there's lecture, then they come in and work on labs on their schedule. This one particular setup is a $25,000 diode laser setup where they make their own frequency double YAG laser. It's kind of like it's a giant green laser pointer that they're making there. But that table holds, right now, the contents of that table and all the electronics and everything on that, you're probably talking $50,000 of equipment just invest in that one desk and its contents. Another college students doing the same experiment here in the center desk. There's 4 laboratories that can be separated by these accordion doors here, so we can configure a variety of things. My high school students are actually in the process of building individual laser systems here. This is a dual-headed laser system that's under construction here to do a variety of things. There's a supporting overload equipment, and you can see the camera system here is set up to actually broadcast what the high school is doing to the students that can't attend in person right now. We've got, I also teach the high schoolers the ARM 15678 electrical sequence. This is a laser light show system that many of you may have seen that students have built over the years to be mobile and transportable. We've got another student working on that. Walking through the mission control. Here's another one of the electrical trainers for demonstrations, and I actually teach the college course, same college course, and the high school students, after seeing demos on these, they go and they use the mechatronics program stuff in the mech lab. Again, this is the backside of mission control. Looking at various laser systems in here. All the rooms have enhanced ventilation and lighting system. I can change the color of the lights in any of the rooms. This is our main fabrication kind of area here. We've got a low power fiber laser, a high powered CO2 laser station back there, low power CO2 laser systems in here, and controllers. This is our big fabrication laser here. This is 450 watts continuous wave or 4500 peak pulse fiber laser that will cut through metal. Not quite a quarter of an inch thick, but you can make and fabricate all kinds of different parts and pieces using this laser. In the back, we've got a YAG laser donated by a company that is pretty expensive. This particular laser system here has got 480 volts step-down transformer. The labs were all electrically wired to be able to accommodate extensive flows of robots and laser systems. Here's another system that's being developed by the high school student. One of the high school students has a transiting welding system. And the back area here, this hasn't been used in roughly a year now, year and a half. It's a bunch of high-end optical type system equipment for the more advanced associate's degree program courses, including scanning electron microscope assembly here and interferometer back that wouldn't make out that well. But we've got an extensive amount of equipment in all the labs. They're all safety interlocked for laser safety, and they've got curtains to keep it dark if we need to do sensitive hologram type experiments. And as I mentioned earlier, we're kind of joined at the hip, right? If you walk through the back door of the lab, and we'll frequently use this. This is the back side of the mechatronics lab, and it's got a bunch of laser equipment in here and the fabrication equipment. We're actually using the FabLite laser to manufacture some parts and components for use in our other equipment. So that's it in a nutshell. Got lots of equipment. Don't have the best storage yet. We're still working on getting cabinetry, but great opportunities for students to learn a wide range of skills in photonics and lasers.